Hey everyone, and welcome to Podcast My Paper, the show where we break down complex research papers into digestible insights for everyone.
That's right, Tom. We're here to take dense academic articles and turn them into something you can understand, ponder, and maybe even use in your everyday life.
And today, we're diving into a particularly important topic, especially given everything happening in the world right now. We're looking at a paper called Climate Change Impacts on Plant Pathogens, Food Security, and Paths Forward.
Exactly. This paper, recently published in Nature Reviews Microbiology, looks at how climate change is impacting plant diseases and, in turn, our food supply.
So, we're talking about climate change, plant diseases, and the future of food. Sounds like a cheerful topic. All joking aside, the team of scientists really did a deep dive in this area, and it's worth unpacking.
Absolutely. It's critical that we understand these connections. Plant diseases can cause massive crop losses, threatening food security, impacting economies, and potentially leading to widespread hunger and instability. We'll walk you through what's happening, why it matters, and what we can do about it. So, let's set the stage. We all know that feeding the world is already a huge challenge, right? But it's not just about growing enough food. We need to protect what we're already growing. Plant diseases are a major threat to that.
Absolutely, Emma. I mean, think about it. We're talking about fungi, bacteria, viruses. These microscopic organisms are capable of wiping out entire harvests. The paper notes that crop losses from pathogens and pests are estimated at $220 billion. That's a staggering figure.
It really is, and it's not just about the money. It's about the availability of food for communities around the world. These diseases can devastate local economies that rely on specific crops, like coffee in Central America.
Right, and these aren't just problems of the past. Remember the Irish potato famine? Or more recently, the coffee rust crisis you mentioned. These historical and current events show just how vulnerable we are to plant diseases. It isn't just a problem for farmers. It impacts the entire world.
Exactly. Plant diseases don't respect borders, and they're becoming more and more complex. This research helps us understand the scope of that complexity.
Okay, so we know plant diseases are a huge problem. But what's the link to climate change? Well, this is where things get even more complicated. Climate change isn't just about warmer temperatures. It's about fluctuations, disruptions, and altered ecosystems, and all of this influences plant diseases.
Exactly, Tom. The authors point out that climate change can exacerbate plant diseases and pathogen spread in a few key ways. It can alter how pathogens evolve, change how they interact with their hosts, and even lead to the emergence of entirely new strains of pathogens.
It's like climate change is creating the perfect storm for plant diseases. Think about it. Warmer temperatures might allow certain pathogens to survive in areas where they couldn't before, spreading disease to new regions. Plus, changes in rainfall patterns can create ideal conditions for some pathogens to thrive.
And it's not just about where the pathogens can live, but how they live. Changes in temperature and humidity can affect how quickly they reproduce, how infectious they are, and how long they survive. This directly impacts agriculture and natural ecosystems. We're talking about impacts on crop yields and biodiversity, including information on current and future impacts of climate change on pathogen biogeography, disease incidence and severity, and their effects on natural ecosystems, agriculture, and food production.
Give me an example of what that looks like in real time.
Well, the review notes that the severity of Fusarium head blight of wheat is likely to increase due to the shift from a milder version that prefers cool and wet conditions to a more aggressive version that prefers warm and humid conditions. So, a slight change in the climate has allowed for the outbreak of a more destructive version of the disease.
Wow, that's a pretty direct link. So climate change is essentially giving these pathogens a leg up, making them stronger, more widespread, and more difficult to manage.
Okay, so we've established that climate change is making things tough for plants, but there's another player in this story we need to talk about, the plant microbiome.
The plant? What now?
Think of it like this. Just like our bodies have trillions of bacteria and other microbes living in and on them, plants do too. This community of microbes, called the plant microbiome, lives in and on the plant in the soil surrounding the roots.
So it's like a microscopic support system for plants?
Exactly, and a very important support system. These microbes can help plants absorb nutrients, fight off diseases, and even tolerate stress. The plant microbiome helps the plant communicate, acquire new phenotypic traits, and primes the plant immune system. It's a pivotal factor influencing plant health.
Okay, I'm starting to see how this all connects. So, if climate change is messing with these microbial communities, it could have a big impact on plant health and disease resistance.
You got it. The authors emphasize how climate change can disrupt the delicate balance of the plant microbiome, potentially leading to imbalances that make plants more susceptible to diseases.
It sounds like this is a key area we need to understand better if we want to protect our plants and our food supply. So, are there certain diseases that the microbiome has been shown to help prevent?
Many. The review mentions that changes in the soil and plant microbiomes may impact infection processes. The microbiome can reduce disease incidence, affect plant physiology, immune response, and can provide a line of defense. Also, beneficial microorganisms can reduce disease in the presence of susceptible hosts and a conductive environment.
This is fascinating. It sounds like, rather than only focus on plant traits or environment, scientists need to consider the microbiome as a key factor when studying plant health too. So, let's get into some specific examples from the paper about how climate change is affecting plant diseases. One thing that really stood out to me was the discussion about elevated carbon dioxide, or CO2.
Ah, yes, it's not just about temperature. We often think about warming, but rising CO2 levels are a big part of climate change, and they can have surprising effects on plant pathogens. It's wild that CO2 impacts the disease itself.
Exactly. The paper mentions that varied disease incidence happens in conditions of increased CO2 concentrations. It seems like some diseases get worse, while others get better. Can you explain that a bit?
Sure. The authors highlight that the responses are actually pathogen and host dependent. Some examples from the paper include that elevated CO2 levels increase the severity of powdery mildew on cucurbits, which are plants like squash and cucumbers, as well as wheat head blight and blotch.
Oh wow, I love a good cucumber. So this means more disease for the poor cucumbers and wheat?
Yep, and the inverse is also true. On the other hand, the susceptibility of soybean towards the downy mildew pathogen was reduced in elevated CO2 conditions.
What? That's so wild, it either gets better or worse depending on the host and pathogen.
Totally. It all boils down to complex interactions between the plant, the pathogen, and the environment at the molecular and physiological levels.
Okay, so let's break that down a bit. What are some of the underlying mechanisms that cause these different responses?
Well, the paper explains that atmospheric CO2 impacts plant immune responses and hormone levels, which then influence plant pathogen interactions. For example, increased basal expression of jasmonic acid-responsive genes under elevated CO2 enhances resistance to some pathogens while reducing it to others.
Okay, I think I get it. It's like elevated CO2 is throwing a wrench in the plant's defense systems, and some pathogens are better equipped to take advantage of that than others. Also, defense effectiveness is reduced with elevated CO2, which has increased the susceptibility of wheat against major pathogens.
Exactly. The interaction can also be influenced by the environment. Different environments can cause specific changes, which leads to alterations in plant pathogen interactions. Also, the review mentioned some experiments where responses were seen in a lab, which could lead to more changes in a real-world environment.
The scientists need to account for more real-world scenarios.
Agreed.
Okay, this is a great example of how climate change can have complex and sometimes counterintuitive effects on plant diseases.
This is a complex problem, but the paper actually offers several paths forward. What are some of the key solutions and strategies they propose?
Well, one of the main points is that we need to rethink our existing frameworks for understanding plant diseases. They suggest that we need to specifically amend our current thinking and include environmental and host microbiomes in our disease concepts to better understand outbreaks and to improve disease management.
So it's not just about the plant and the pathogen, but also all the other microbes that are living in and around the plant?
Exactly. All these factors can contribute to the success of disease outcomes.
And how do we accomplish that? That sounds like a big task.
It is. But one way forward is to bring in eco-evolutionary theories into research. It will improve our mechanistic understanding and prediction of pathogen spread. We have to make a shift to consider all of these factors together.
Okay, so that's a more holistic approach to research and understanding the problem. What about practical steps we can take to actually manage and mitigate disease outbreaks?
That's where things like monitoring and sustainable management come in. The authors emphasize the importance of having systems in place to track the emergence and spread of plant pathogens. This would help us to detect problems early and respond quickly.
So, is there a way to detect a plant problem early?
You bet. We have to integrate tools like artificial intelligence and machine learning to observe changes and potentially detect the diseases.
That makes sense. And when it comes to management, they're advocating for more sustainable practices?
Yes, definitely. We can use less ecologically harmful tactics as opposed to harmful pesticides. Also, we need a science policy interface that makes sure our decisions are well informed.
So, sustainable management tactics can help to inform policy and create a science-based plan. So, where do we go from here? What are some of the potential applications of this research and what's the bigger picture?
Well, one of the most exciting possibilities is that this research can help us develop climate-resilient crops. We can breed or engineer plants that are better able to withstand the challenges of climate change and resist disease.
That would be a game changer for food security.
Absolutely. And it's not just about crops. This research can also inform better disease management strategies in natural ecosystems, helping us to protect biodiversity and the health of our planet.
It sounds like a lot of this research is about predicting outbreaks. Are we talking about a plant pandemic early warning system?
Yes, and this is a crucial step. The paper calls for a global, coordinated effort to address this challenge and mentions we should take a big picture approach.
So it sounds like it could get overwhelming very fast if we just focus on the individual level.
That's right. We have to consider all levels. In particular, we need to take all levels of data and make a plan that incorporates the policy level too.
It really underscores the importance of working together on a global scale, so we need to focus on getting all groups to the same table.
Precisely. By prioritizing a science policy interface and social innovation, we can take proactive measures to protect food security and environmental sustainability for generations to come. Well, that about wraps up our discussion on this fascinating paper. Emma, thanks for lending your expertise.
Always a pleasure, Tom.
And a big thank you to all of you listeners for tuning in to Podcast My Paper. We hope you found this deep dive into climate change, plant pathogens, and food security as interesting as we did.
Absolutely. We really only scratched the surface, so we encourage you to check out the full research paper for all the nitty-gritty details. And if you're curious to learn more about this topic, there are tons of resources out there.
Also, let us know what papers you want to hear about next.
Until next time, stay curious.
And keep your plants healthy.